Hi, Assalamualaikum and good day. So now we move to the third part, still under Titrimetric method. So for the first part and second part, you guys already know what is the Titrimetry and how does the reaction of acid and base can be occurred, and what are the indicator to see the end point of the reaction if they got the complete reaction. And while on the second part, you already covered on the reaction of the strong acid with the strong base or strong base with the strong acid. Now on the part 3, will be learn on the third scenario, which is weak acid versus strong base. Okay, so again, you already know what is a strong base, right, from the previous lesson. So now you must also know what is the weak base and also what is the weak acid. Okay, so in this particular example, the weak acid that we use is the acetic acid. Okay, so the titration of 100 ml of 0.1 molar acetic acid with 0.1 molar sodium hydroxide. So the neutralization reaction is as follow. Okay, to perform the titration curve, we have to identify 4 points. Before titration started, equivalent point, and excess of the titrant. Okay, so these are how the titration curve will be looks like. So this to be easy. So before the reaction started, before the equivalent point, and excess of the titrant. So example 1, a 50 ml aliquot of 0.1 molar acetic acid is titrated with 0.1 molar NaOH. Calculate the pH of the solution after the addition of 0, 5, 25, 45, 50, 55 and 75 ml of NaOH. The dissociation constant for acetic acid is 1.75 times 10 power of -5. Okay, before we go further, in this titration, we will introduce you the dissociation constant. So we will call as a Ka for acid and Kb for the base. Constant for acid Ka and constant for base Kb. So for this is constant for the acid Ka, 1.75 times 10 power of -5. Okay, first of all, add 0 ml of sodium hydroxide. So as the previous equation used, just use the equation and put as it is. Okay, so the Ka value for this is 1.75 times 10 power of -5. Okay, the POH, if negative log, 5.35 times 10 power of -6 equal to 5.27. Therefore, the pH is 14 times 5.27. 0.27 equal to 8.72. Okay, here we find the kW. kW is the constant dissociation for the water, which is 10 power of negative 14. 10 power of negative 14. Okay, and pH plus pOH equal to 14. Okay, excess of the titrant. So pOH negative log OH equal to negative log 4.76 times 10 power of negative 3, which is 2.32. Therefore, the pH is 11.68. So now, after you already calculated all the plots, all the points before, during, equivalent point, and after equivalent point, then you might plot the titration curve. And last scenario is weak base versus strong acid. Okay, so weak base and strong acid. In this case, the weak base is the ammonia. Okay, again, we must get 4 points minimum, at least 4 points before titration started. Titration proceed, or equivalent point, and midpoint of titration. So here, since the titrant is the base, therefore we use the dissociation of the base, which is constant base. Okay, KB, constant dissociation of base. So equivalent point, so excess of the titrant. So this how does the titration curve looks like. Okay, so please try this example. Oh no, we provide the solution. Okay, so these are the solution. KB is given as 1.75 times 10 power of negative 5 for the ammonia. Okay, addition of 10 ml of HCl. Okay, addition of 50 ml of sodium hydroxide, where this is the equivalent point. Okay, the pH is 5.27. And finally, excess of the titrant, and the pH is 2.32. So after collected all the 4 points, then you must be able to plot the titration curve or exercise. So all the best. See you. Bye.